Hello dear learners. In this session, we will be looking at different types of sampling designs. When we say sampling, it's basically a fundamental process of selecting a subset from a large population as we discussed in the previous session. Now, when you have a bigger population, like a few thousands or sometimes even lakhs or crores of items or elements. Now, if you remember in the last class, I gave you the example of St. Aloysius Deemed University, where we have 8,000 students. Now, if I have to do any study on the students of St. Aloysius Deemed University, it is very difficult for me to collect data from these 8,000 students. So what we will do is, we will select maybe 100, 200, 300, 400, or whatever the feasible number of sample we think is appropriate, or we find it appropriate as per the statistical formulas, and then determine this subset of the population as our sample. Right? Now this classification branches into two methods, predominantly known as the probability and non-probability methods, and then there is something called as complex random sampling techniques, which basically combines multiple probability or non-probability sampling techniques together. So you can broadly think it as three categories of sampling techniques. The first category we will go with is the non-probabilistic sampling, or also called as the non-probability sampling, where the odds are unknown, right? Uh, you cannot calculate as to what is the odd of a particular element in the subset is getting selected for the particular sample, right? This is a technique that is where mathematical probability of selection is unknown, and therefore it is also called as purposive, deliberate, or judgmental sampling, right? You cannot predict that, okay, out of 8,000 students, every student has 2% chance of getting selected into the sample. This kind of statement cannot be made when you talk about non-probabilistic sample, because uh, you cannot calculate the mathematical probability. When you look at the different types of non-probability sampling, the first one you have is convenience and accidental sampling. Now, this is a collection from most accessible locations. Like the name itself suggests, it is based on convenience. So when I say I am studying the behavior of students, or I am studying the preparation pattern of students before examinations. Now, in this case, I have stated students. So whichever student I find, I collect data from them, because my population or my target audience is student. And here I am not going to specify where these students are from. Are they from Aloysius, SDM, Nitte, or Sahyadri? It doesn't matter, or I don't pay much attention to that. What I simply do is, whenever I find a student, I ask them to give data, or I collect data from them and use that data for my study. This is called as convenience sampling. So based on your convenience, based on uh, the ease of accessibility, you collect the data from. The second one is purposive and expert sampling. Here the selection is based on the researcher's knowledge or from a list of known experts. Now, in case of purposive sampling, what you do is, uh, you know that, okay, for this particular study, only this X and Y or Z person can be included, because they possess the characteristics that is required for the study. For example, I want to study, uh, investment behavior among undergraduate students. Now here what I'll do is, based on the knowledge I have about our students as to who is interested in investing, or generally who talks about investing or who is involved in investing. So based on this information, I include them in my sample and then I collect data from them. So here, like again the name suggests, the subset or the sample is selected on the basis of the purpose of the research. If a particular person or an element satisfies the purpose of the result, then they have the chance of getting selected into the sample. The next one is quota and diversity sampling. Uh, Quota is wherein it ensures groups and are proportional. What usually happens is, let's say, when I'm taking the example of, again, St. Aloysius deemed to be university students, 8,000 students are there. Imagine out of these 8,000 students, 60 percentage of the students are male and 40 percentage are female. Then I am selecting a sample. Let's say my sample is 100. Now, since out of 8,000 students, 60 percentage were male and 40 percentage were female, I will maintain the same ratio. I maintain the same ratio in my sample size as well. So when I say 100, out of 100, 60 will be male, 40 will be female. So I'm maintaining the same ratio. Or if I'm taking a sample size of 200, 120 will be male and 80 will be female. Now this is because in the population, the total students of St. Aloysius Deemed University, 60 percentage are male and 40 are female. I'm going to maintain the same ratio when you talk about my sample size as well. That is what's called as quota sampling. Then you have snowball and model instant sampling. Now this is wherein I don't have much information as to where my potential respondents are. I know one person, one student who invests in stock market. So I go to him, I collect data, and then I ask him, do you know anyone who, and then go to that person and collect data from them. And I'll ask this second person, are they aware of any students who are investing in stock market? So I go and collect data from them. And then again, I go and to that person and ask that person, if they know anyone else. So like this, from one person to another, I go on asking for leads basically. And with the help of leads generated from each individual respondents, I will collect, sample that is required, or I will reach my sample requirement. The next one you have is probability sampling techniques, or what's called as random sampling technique. This is wherein each and every participant has equal percentage or equal probability of getting selected into the uh, sample, right? It has a specific defined frame. Let's say, if there are 100 people, every one of them have 1% of chance of getting selected into the sample, right? That means, you don't have any specific, what you say, judgment, purpose, or convenience based selection. You apply any form of technique which will help you in selecting this. Now here in probability sampling, you first define the population frame, that is the number of units that exist in a population, uh, you know, from 1 to finite. Then determine the final required sample size, that's usually referred to as n. And then you can what you can do is, from, let's say, if the population have 100 people and you need only 10, that is your sample size, you give numbers from 1 to 100 for each person in the population. And then you choose a starting point and go on selecting numbers at a particular interval. That's it. Person number 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. So this way I will reach at my population size of 100. and from that population I would have derived a total of 10 as a sample. Right. The last category is complex random sampling designs, where you have multiple techniques used together. You have something called a systematic sampling, where members are selected or of fixed periodic intervals calculated by dividing the population size by the sample size. So if there are 100 people, if the sample size is 10, so I do 100 by 10 and the number I get is 10. So every 10th person I will go on selecting for my sample. So the 10th, 20th, 30th, 40th, 50th, 60th, 70th, 80th, 90th and 100%. These 10 people will be a part of my sample. Then you have something called as stratified sampling, wherein the population is divided into what's called as strata, that are groups or brackets. So what you do is you divide the population into groups first and then select a sample size from that group. For example, okay, let's take the example of BBA. So I want to collect data from 30 students. So what I will do is I will take BBA. I will divide BBA into three strata: first year, second year, and third year. I will select 10 people from first year, 10 from second year, and 10 from third year. So this way, I will reach my sample size of 30. Now this technique is called as strata or stratified sampling because I am making the population into smaller groups and then selecting, sample from these smaller groups. This way, it ensures that the sample is actually representative of the characteristics shown by the population. Next is cluster and area sampling. Now this is wherein you select a sample or select people for a sample from the population based on geographic blocks, right? I'm studying the behavior of students with relation to their study patterns. So what I'll do is I'll select clusters such as city, rural area or suburban area, and I will collect 50 students data from city, 50 from suburban and 50 from rural area. So this way I have created clusters or geographical blocks, and from these geographical blocks and clusters I am going to collect the data. Or you can divide these on the basis of existing areas as well. When you're looking at a particular state, you might consider collecting data by dividing the state into metropolitan city, tier 1 cities, tier 2 cities, tier 3 cities, and thereby ensuring that you collect data from all these three, or ensure that the sample consists of respondents from all these four groups. Multi-stage sampling, this is where you have divided the larger population into multiple stages and then collect data depending on this classification. That is, for example, if I am looking at the country, then I will divide it on the basis of states. States further I will divide it on the basis of districts, and from districts I can further divide it on the basis of cities, towns or villages, and from these villages or cities or towns I can further divide it on the basis of sectors or blocks or households, right? So I will go on classifying at multiple levels, and then from each of the final levels I will collect few samples. And finally you have sequential sampling, wherein this is one type of method where the sample design is such that the number of people required in the sample is not determined in advance. In all the other methods, you know exactly as to what your sample size will be: 50, 100, 200, 500, 1000. You know exactly what is your sample size, and from the population you select that many. But in case of sequential sampling, you don't know what the sample size is. So you start doing your data collection or selecting a sample, and as you progress, as you proceed with your data collection process, then you go on determining what could be your sample size. So it's a simple, random sampling technique, but then it is designed in such a way that the number of sample size required is not fixed. That is determined as and when the need is, or how the need is. So for that reason, this particular technique is also referred to as sequential sampling.